Hi, today I'm going to show you how to use CodeWalker to instantly dissect one of the hardest programming concepts to understand, multi-threaded code. Many new programmers assume that multi-threaded code will operate synchronously if two threads are fired off at different times. Or maybe they'll fire off asynchronously, one right after the other. In practice, experienced programmers know that this is seldom the case. This code will create two threads. Then each one will wait for a second and execute. Each thread will do this 5 times. Until now, seeing how this mechanism actually works has been impossible. But with CodeWalker, we're going to turn that impossible into trivial. First, let's open our simple example file in CodeWalker. This is what it looks like in CodeWalker. Let's open the Filters panel and click on Calls. This is going to show us distinct calls as different colors. It shows all of the possible execution branches with each subsequent piece of code attached afterwards. Now let's go build that code and turn it into an executable. We're using Ubuntu for this part of the code. First, we're going to build our executable. In this case, we're going to use GDB to debug this. So back in CodeWalker, we'll click the GDB button in the retrace window. This is going to generate a GDB script. Now let's run the program using GDBServer, and let's also run our script. When it's finished, it creates a retrace file. The retrace file format is open and well documented, so any debugging scripts you create can easily generate one. Now let's open CodeWalker again and load that retrace file it generated. The first thing it shows us is the first path execution. We can immediately see that it's calling into main and executing that first line there. Let's see what happens next. We'll press the forward button once. It tells us that the next function that's executed is myThreadFun. Well, that makes sense. We've executed this, we created our two P threads, and one of them called myThreadFun. Clicking the button again, we see a green line. That means a second thread has entered this. So there are two threads, both executing myThreadFun. At this point, we're inside our threads. Both have been created, both have been called, and in theory, both are going to go to sleep for a second, and then both are going to wake up and execute. Let's see what actually happens. We can press the forward button to walk one step through the execution. So we see here that thread 894906 just executed, and it is called other function. And we now see that 894905 has executed and has called other function as well. Well, that's fine. That's the order they went to sleep in. Clicking the forward button one more time, we see that 905 executed first. That was a little unexpected, because we would think that since this is multi-threaded code, that the other one might get to go first. But that's not actually how multi-threaded code works. So you can very easily and quickly see exactly how all of your multi-threaded code is going to work. Now this is an interesting thing here too. Watch this. We can step backward and forward. We see here they're basically in lockstep. One is happening right after the other. Okay, so we have 905, 906, and then 906 is executed again, calling back an other function. 905 has done the same thing. So 905 again went first, and then 906. See, these are happening out of order, and you wouldn't know that unless you were really paying attention to the thread IDs and paying attention to the order of execution. We could also open the Filters window and turn on the retrace feature there. This is going to filter out everything except the parts of the code that were actually executed, giving us the ability to instantly see exactly where all of our threading code touched and exactly in what order it executed. And this is how CodeWalker helps you understand multi-threaded code better than traditional debugging tools.